Okay, we're going to do a quick review of the multiplication of matrices. Now, we're talking about the multiplication of two matrices. Okay, and this is not a scalar multiplication, which is scalar being a real number. Okay, we're doing two matrices, and we are looking at situations where we have matrix A multiplied by matrix B, and we need to look at, for each of them, we need to look at their dimension or the order. Means the same thing, and that basically refers to the size of the matrix. Okay, the number of rows by the number of columns. Remember that? Rows by columns. So looking at matrix A times matrix B, we need to look at the dimension. We need to look at some natural number times some natural number in terms of describing the dimension of each matrix. So if we say matrix A has dimensions m by m, so m rows n columns, and b n by p, okay, that's a way of describing rows and columns, number of rows and the number of columns. Okay, so we can see that the number of rows of matrix A doesn't necessarily have to equal the number of columns of matrix B, but in order for them to be what's called conformable, we need to check something. And what that word was, conformable. Now that means they're actually able to be multiplied. So if they are conformable, they're doable. Okay, so we've got this value here was n. Okay, now these are all real numbers. If you know matrices, you probably know that. Okay, so they're all natural numbers, I should say. So we have to have in the first matrix, we have to have the number of elements matching such that n equals m. So the number of columns of A must match the number of rows of B, and then they're conformable, and you can then multiply them. So in this case here, we have 2 by 2 matrix, and we have a 2 by 3. That's like saying the first one's A and the second one's matrix B. And we can see that these are conformable because the number of columns of the first matrix matches the number of rows. The number of rows in the second. The other thing we find out here is gives us the dimension or the order of the second of the result. So that the 2 and the 3 on the outside, that means that there'll be an answer that is a 2 by 3 matrix. So the dimension of the resulting matrix will be a 2 by 3. So let's have a look. So the algorithm that we need to use for matrix multiplication is, in the first instance, we think about the 2 by 3 matrix that we're going to get. The first part will be working, so I'm going to leave plenty of space there. And what we'll find is that as we go along, the row 1 of the first matrix will go down column 1. So I'm not there, that means with column 1 of the second matrix. Okay, so row 1, column 1, so that's matrix A, and that's matrix B. So here we'll get 2 by negative 2 plus negative 1 times positive 1, negative 1 times positive 1, and we compute that on the next line. But what we need to know there is that we have a 1 and a 1 down the bottom here. So we have 1 and a 1, and that puts the result that goes in position 1, 1. Okay, so that is no accident. That will occur the right way through. So it does help us work out where all of these values go. So we move along now. We're in row 1, column 2 of the resulting matrix. So we go along row 1 and down column 2 of the second matrix. So we've got 2 times 0 plus -1 times -1. And for the thing that goes in position 1, 3, row 1, column 3, we go along row 1 of the first down column 3 of the second. So we have 2 times 3 plus -1 times 5. And in the second row, we'll have in position 2, 1. So that'll be position 2, 1. Okay, that'll be position 2, 1. That'll be 2, 2. That'll be position 2, 3. We have the corresponding rows and columns working together in the same way. So the thing for 2, 1 will be row 2, column 1, 0 times -2 plus 4 times 1 and 0 times 0 plus 4 times -1, and then 0 by 3 plus 4 by 5, and that finishes it off. And all we have to do now is compute that, and we've got our answer. So in position 1, 1, we had 2 by -2, which is -4. -4 minus 1 is -5. And no, you shouldn't really put commas in there. I was only doing that in the working there to separate the working. Don't put commas in matrices. Position row 1, column 2, that's 1. And the final one on row 1, 2 by 3 is 6 minus 5 is 1. Okay, in the second row we have 4, we have -4, and we have 20. So that's how we multiply two matrices together. We check that they're conformable, and then we can anticipate the size of the resulting matrix, and we ensure that all the calculations go in the correct space, which yields a matrix with the correct values in the correct space. Have a great day.